So when we're asked to graph an absolute value function, some of them are pretty simplistic to graph because they behave just like parabolas. Some are not so much because when we end up with two absolute value components within an equation, it changes how we have to deal with this. So basically, each absolute value component has to be, you have to take the absolute value prior to adding it to the new one, or the other absolute value component, and that changes how we look at things. So basically, we need to look at our graph as a section of chunks. So I'm going to ask that you remember this definition that we talked about on the earlier page. And what, when x is less than 0, that means we're plugging in negative x, or we're going to get a negative x, right, within the bars. If I'm plugging in a value greater than 0, it means that I'm going to be getting an x within the bars, okay? Positive x within the bars. So the best way to do this is to look at each absolute value part of the graph by itself and use this definition. So the first thing I'm going to do is I'm going to say the x minus 2 is greater than or equal to 0 because I want to find out, you know, I'm looking for my boundaries here actually because I'm trying to make sense of what this graph is going to look like. Okay, so that means x is greater than or equal to 2 and x is less than 0. Since I did it for this one, I'm now going to do the same thing for this one because I'm looking, I need to know what I'm getting out here. I'll show you why in just a second. Okay, when I solve for this, okay, I end up with 4 different, oops, this should be a 2, sorry about that. I end up with 4 different boundaries. I'm going to highlight where these boundaries occur on the graph, and then we'll sketch the graph. So x is greater than or equal to 2. So I'm going to have something here. Okay. I'm also going to have something where x is less than or equal to 1. And then I have these guys here. X is less than 2, but x is also greater than 1. So I have a little section here. Each section that's color-coded, the blue, the pink, and the purple, is going to have a different behavior. So here's how we figure out what those behaviors are. Okay, so let's start with x is greater than or equal to 2. So I'm going to take the absolute value of x minus 2. Okay, and if I put a value in for x that's 2 or greater, like if I put 2 in, I get 0. If I put 3 in, I get 1. Am I getting a value within the bars that's positive or that's negative? In other words, greater than 0 or less than 0? And the answer is I'm getting a value that's greater than or equal to 0. That means whatever in the bars is going to yield a positive x. So I'm going to say this. Okay, we're going to do the same thing for x minus 1 because these guys are getting added together and I need to know what I need to add together. Okay, so if I put a value 2 in for x, I end up with a negative number. If I put 3 in, I end up with a negative number. That means every value I put in this domain is going to be less than 0. That means I need to take what is in the absolute value bars and I need to negate it. Okay, since this is the sum, I'm now going to sum x minus 2 with negative 1 plus x. So when I do that, I get x minus 2 minus 1 plus x. I end up with 2x minus 3, and I'm going to graph that with the domain x is greater than or equal to 2. So if I plug 2 in, I get 1. And then this is just going to go up rapidly because when I plug 3 in, I would get 6. Okay, so there's that part of the graph. Okay, the next part, let's do the middle part. Okay, we're going to do the same thing. If we plug a number into our original that's between 1 and 2, but not inclusive of either of those, I get all negative numbers, which means that x is less than 0 within the bar. So I negate what's inside. Okay. When I do the same thing for the absolute value of 1 minus x, plugging in a number between 1 and 2, like 1.5, I end up with negative numbers every single time. So I negate what's inside the bar. Okay? And now, because this is an added set of absolute values, I'm going to combine them, and look, I'm left with 1. So I have a horizontal line from 1 to 2. Okay, and the last one, same idea, except now I'm looking for values with the domain less than or equal to negative 1. Alright, so if I plug 1 in, I'm getting a negative number out. If I'm plugging 0 in, I'm getting a negative number out. Negative is also code for less than 0, right? Which means I use this definition. I negate what's inside the bars. Okay. Same thing here. I'm plugging 1 in, and I get 0. Plug 0 in, I get 1. I plug negative 1 in, and I'm getting all positive numbers because that's 2. So I'm getting greater than or equal to 0. So what's inside the bars is equal to what's inside the bars here. Okay? So, equal signs. I'm going to add these together, and I end up with negative 2x plus 3. Okay? So here's my plus 3 part. That's my y-intercept. And here's my other point. And notice I'm stopping here because this is the only part of the function. I'm looking at the piece of the function. So this is the graph of y equals the absolute value of x minus 2 plus the absolute value of 1 minus x. Alright, so the last thing we're going to do is we're going to look and think about the modulus in terms of maybe identifying a domain. So here's the situation. I'm looking for a value that's going to equal 5 if I substitute it in for x. If I put 5 in for x, I get 5 out. If I put negative 5 in for x, I get 5 out. That's the or equal to part. The question now is I need x, the absolute value of x, to be less than or equal to 5. So let's deal with the less than part. To make it less than, I need to put a number that's less than positive 5 in, like 4, because that's absolute value of 4 is still less than or equal to 5. The absolute value of negative 4 is still less than or equal to 5. So what I'm going to find out is put in all of these values in that I'm highlighting green actually is my domain. As soon as I go above, or as soon as I'm lower than negative 5 or greater than positive 5, I'm outside of this boundary. So my domain would be x is greater than or equal to negative 5, but also less than or equal to negative 5. This rule works every time if all you have is a singleton x inside the absolute value bars. And we'll actually get to the technical definition of that rule in just a second. This one is a little more complicated because we're trying to figure out what I need to add to 1 so that I'm less than or equal to 6. So the biggest number I can add so that I'm equal to 6 is 5, right? Because we're doing the equal part. On this end, I didn't leave quite enough room. If I put negative 7 in for x, negative 7 plus 1 is negative 6, and the absolute value of negative 6 is 6. Okay? I'm looking for things that are less than 6 now when I take the absolute value of them. If I put anything in between here, like negative 5 and negative 5 plus 1 is negative 4, and the absolute value of negative 4 is less than 6, as is when I put 4 in, 4 plus 1 is 5, the absolute value of 5 is less than 6. So all of these values are the domain for this problem. Now, here's what makes this interesting. If I were to make this 0 inside, what would x have to be? It'd have to be -1, right? And what happens when I add -1 to 6? I get out 5. What happens when I subtract? What happens when I take -1 and I subtract 6? I end up with -7. So instead of having to do a number line, there's some tricks, and here these are as rules. So if A, this is A, oops. So if A is greater than 0, keeping in mind this is A, then the absolute value of x is less than or equal to A. That's equivalent to saying x is greater than or equal to -A, but also less than or equal to A. So we're finding all the values for which this statement works, okay? We can also do that when we've got something that's being added or subtracted, okay? So when A is greater than or equal to 0, then the absolute value of x minus k is less than or equal to A is equal to, remember how we went through and found out what x would have to be to 0 this? That becomes k minus A right here, okay? That's for the left-hand side, the lower part. X is greater than or equal to that, and x is also less than or equal to positive k plus your A value, just like we did on the prior page. That wraps up this introduction to the modulus.